Welcome back to our thinking about how to plot things on maps using Python. Last time we did all the work to get our data organized and then plot it on top of a map of California. So let's just walk through that again. We had defined some functions and imported some libraries. Then we went and found data from the web and imported that into a data frame with inside pandas. Or using pandas, we made a data frame. It looked like this. Again, these are just the first 5 rows of many thousands. And then, and it turns out that these are for cities in California. Then we plotted just that data as like a scatter plot, XY scatter plot, using a different way of calling this, where we said the data we wanted to use, and then that we were making a plot of it, and then we specified the kind. And then the last step was to take that same idea where we said we're going to plot from this data the longitude and latitude, but then we also showed an image of California, the map. And we had set it up correctly so that the extent of our data, or the extent of this map, matched the extent of our longitude and latitude, and that put all the points correctly inside of California. The last thing we talked about was that we can set alpha values for things like the maps and the housing. I'm going to leave this exactly as it is, so instead I'm going to just repeat this by copying it and pasting it down here. I don't need to import these libraries again, because once I've imported libraries or pieces from it, it's inside the kernel and I can access that. So then let's just, here it is, same thing that we have here. And what we're going to do is we're going to play around just a little bit with how we might want to display this data. Again, we have the alpha here set as 1, and we said that this is for the scatter points along x and y. And so one of the things we could do is that if we wanted to see them easier, we could set the alpha to something like 0.5. And if I hit play, you'll see that I can see this overlap. And again, I could like make it even more transparent if I wanted, 0.1, and then those points would fade even more. And now I start to see for real the population centers in California. We have San Diego, LA, Santa Barbara, Santa Cruz and Monterey, San Francisco area, out into the Bay Area. This is Sacramento, the capital, and then the corridor that runs down that through Fresno and Bakersfield in the Central Valley. Then this is Lake Tahoe over here, and a few of the inland empires and places like that. Up here is Eureka and a big old fishing area. Okay, that's one way that we can see this. Some other things that people sometimes like to do is that they like to scale the size of the points by something that would help you see how populous everything is. And so you might imagine that like maybe what we would do is we would make points where there's more population larger and points where there is less population smaller. How might we do that? Well, one of the things that we could do is we could just use the data that we already have, which is information about the population of each of these cities, and then use that to scale the size of each of these points. So let's give it a try. What I'm going to do is I'm going to make this maybe hopefully a little bit more readable by introducing a space here between these two. And then as long as I have this parentheses open and closed, I can also move it to a new line and it will still work. So you'll see I had the same plot. And why would I want to do that? Because I can start to introduce other aspects of the plot that I could change. For instance, the size of the point. I can use the keyword S for this and then give it a size. For instance, I could give them all a consistent size of like 1. Let's see what that looks like. Now all the points are smaller. They still have that transparency and we see where they overlap, and so we start to see the structure of the cities even better when we do that. Maybe what I could do is change the alpha back to 1 so that there's no overlap and you can kind of see what's going on. Now I have a bunch of small points, whereas if I have this as like 5, then I have larger points. If I had it as like 10, I have even larger points. Great. So again, one of the things you might do is say like, well, couldn't we just set the size according to something like the data we already have up here for population? And so one way to do that is to say instead of s equals 10, s equals housing, which is our data, and then the key word for it, which is population. Again, this is us referring to the data sort of by the name of the column. It's a dictionary-like operation if you're familiar with that in Python. This is the end of this function plot, and so maybe to avoid confusion, I'll even put it down on one other line. So we have calling by population, and the size for each city now is going to be scaled by this population. Let's go ahead and hit plot or run and see what happens. It's taking quite a while, and wow, it's wild looking. And why is that? Well, look at this. There's like a massive circle, and it's maybe because like the populations can be quite large. So if I look up here and I look at population, I see numbers that are like 2,401, 322. What I want to do is like reduce this by an amount in this plot. And so maybe what I could do is instead of housing this population size, I want this to be like 1/10 of what it was. And then we can see, oh, does that work? How does it look? So I'm just dividing every population by 10. Now I still have giant circles, but at least they don't all overlap. Let's go even smaller. So now I'm going to divide each population again. It should be 500 instead. And you can plot that, and yeah, maybe that looks all right. And then I have all these overlapping points, and so maybe instead of this being 1, I want it to be 0.1. Now I have something where like these population centers start to like blur together again, and it starts to look like maybe what we expect. However, I actually think that I don't really like the scale working this way, where the population determines the size. And so like another way to remind us of what's going on is I could add a label into here. And so let's say label equals population. And generally I don't like using keys, but in this case maybe it's okay to think about what's going on. And you'll see it added this element here where it's telling me that like the size of this plot is somehow scaled with population, or that the points are representing population somehow. And one of the reasons I don't like this is like our perception of area is sort of problematic. And so I think we can do better than actually just increasing the size of this versus not. But maybe this looks reasonable to you, and so you want to keep it as an example of something to compare to. So I'm actually just going to go down and paste a new cell so that we have this to directly compare. And maybe you can decide that like this doesn't look that great and this does look better. And so right now we have a pretty nice working example of something that could be okay. But maybe we could do something that's nicer, like I say. And one of the things I think we could do is actually use the alpha to give us this information, because what would happen if I took this away and just said I want again the size to be 1? Now I have the alpha controlling the overlap and the size being consistent, and really like all that's happened is I've lost a little bit of area, but maybe to me it's like even the detail looks a little bit finer, and I can really see where these population centers are in comparison to each other. And so maybe the alpha is like a better scaling factor for us. What if instead of alpha being 1 or alpha being 0.1, right? So 0.1 is what we saw here. If I make it 1, everything's going to be consistent, and I can still see these population centers, but it doesn't quite show up as nicely as here. What if the alpha was scaled by the population? So what if we had housing and then called this population, so that we're now scaling what our alpha value is by the population. Let's see what happens. Oh, it threw an error. Why is that? Well, you can scroll down. There's like all this scary text. Look at all this. And it says alpha must be a float or none. Okay. Well, what this means is that matplotlib is only expecting a single value when I have something like alpha. And so it only expects that each individual point will have exactly the same alpha as every other one, and that I can't just point it at the data. So how could we get around this? Well, I think one of the ways that we could do it is that we could use one of the specifications of color to introduce alpha. And so it turns out that if I think about color, I could have red, green, blue as a specification of color, but also alpha. And so there's a system called Rgba, which is red, green, blue colors, and then alpha. So I could say Rgba alpha, let's call this list. I don't know, it doesn't really matter what we call it. And then what I want to do is specify that this is going to be like maybe like a NumPy array that's composed entirely of zeros, and that it has the same length as something like the housing populations, or population, I guess. Okay, and so what we're doing here is that I'm saying I want NumPy to create an array that's going to have a bunch of zeros, and that array needs to be as long as the number of entries I have under the population. And then I want to also say that because I need a red, a green, a blue, and an alpha value, that I want there to be 4 columns inside this array. And so then I'm going to just say comma 4. So now I've made an array. It's going to have zeros. It's going to be as long as the population, and then there's going to be 4 different columns essentially within that array. Now we haven't had NumPy introduced yet, so I need to import NumPy as np. Now let me run this just to verify that it's going to work. I am missing, yes, length, zeros, 4, 4. Okay, there we go. This is the correct syntax for this command. And so we have the same issue that alpha must be a float or none. And so in the structure of these colors, I give it a red value, a green value, a blue value, and then an alpha value. So the first column of our 4 columns is the red value. The second column is the green value. The third column is the blue value. The fourth column is the alpha value. So what we want to do here is we want to say that our Rgba list is going to have in the 4th column, and the way that we count again is starting from 0, so that's number 3. In the 4th column, this is going to be our housing population. And I forgot to use my quotation marks. Great. Now, again, we still have this same error that says we're still trying to feed it the wrong thing. But now we're prepared, because instead of feeding this an alpha value, what I could choose to feed it is that the colors are this. So let's say color equals housing population No. Color equals Rgba list. So we're using C as a keyword for color. We're going to have 0 value for red, green, and blue. And because this is an additive system, that means there's no red, green, or blue light, which means we should have black points. And then the alpha depends on the population. So let's go ahead and try this now. Still an error. Why is this? It says argument has this many elements, not acceptable with X and Y, and you look and you say, but don't these all match? Well, actually the reason this doesn't work is because alpha has to run from 0 to 1. But the population has values like 300, 2,000, 400, and so on. So what we really need is to normalize that. We want the population values to run from 0 to 1. And the way we do that is that we divide every value within the housing population by its max value. So we have the max of housing. Well, in fact, let's just do this the easy way so you don't have to watch me type crazy stuff. Housing max of the population. So now what this is saying is that we're going to go in, we're going to find the maximum value of the population, and then we're going to divide every value in the population by that maximum value. What that means is that the largest value we're going to get is 1. So right here we're normalizing the population data to use for alpha. Now we're going to actually have a list where all the values in the alpha position range from 0 to 1, and when I hit enter, we'll get something that does not throw an error. And I don't know why it didn't run right the first time, but now you can see this is what we have. The alpha values, now every point here is exactly the same size, but some of them we see more than others because we've now scaled the alpha by the population.